I'm going to work through a pretty good chunk of this factoring and greatest common factor review with you using my handy-dandy chart here if I need it, okay, for what I'm doing. And the biggest thing here is going to be figuring out again, and we'll make mention of it one more time here, when I'm finding a greatest common factor, okay, I'm looking for the biggest number that divides into all the numbers. So like my first job here on number 1 is going to be to find the biggest number that divides into 16 and 6. And once I do that, oops, we're going to be looking for the smallest exponent that all terms have. And what I mean here is, like if I notice both of my terms have an x or a y or whatever it is, I'm just going to take the smallest, want the smallest variable, and I'll pull that out. So here's how this works. My first job here is to find the biggest number that divides into 16 and 6. Now if I know that off the top of my head, sweet. If I don't, I always have the option of coming to this chart and saying, okay, I need to find 16 and 6 in one of these rows. And if I do 16 and 6, I just follow along back to the edge and go, oh, it's 2. Okay, so I'm pulling out a 2. When I look at the variable part, both of my terms have an x, but I want the one that's got the smallest exponent. And if I don't see an exponent, that's the smallest one. That's like having an x to the first. So I'm going to pull out an x. If you want to put the 1 there, you can. Okay, that is my greatest common factor. But I'm not quite done. Then I'm going to take what's left over and I'm going to do this parenthesis thing. It's like we're getting ready to set up for the distributive property. So just a reminder here again on how this works. And I'll just do this on the first one. I'm trying to figure out 2x times something equals 16x squared, and 2x times something equals 6x. I'm just trying to figure out what goes in here so when I do the distributive property I get the question back. All right. So 8, 2 times 8 is 16. And if I look at my x's, 1 plus 1 is 2. So 8x. And then 2 times 3 is 6. But I already have 1x, so I don't need any more. That's how I build these. If you're more visual in the way you think and you need to visually see, okay, it's this times something equals, okay, do that. Okay, it doesn't take that much more time to get to the right answer. Now some of you can just look at it and know, and that's okay too. But that's the idea that we're working behind these. Okay. Now they can get a little dangerous though. For instance, number 2 is one that can be a little dangerous in a couple of ways. And here's why that is. So I'm looking here at number 2, and I'm looking for 10 and 20. Now I see 10 and 20 right here, and I work over, well, it's 2, and I might be tempted to write 2. But yeah, let's see if there's a bigger one. I might do a little cover up here for a minute, but that's okay. Ooh, there's 10 and 20 again. But 10's the number on the edge. I always want the biggest number. So if you see a pair, look a little further, make sure there's not another pair. So 10 and 20, 10's the biggest number that goes in. So I pull out a 10. Then what's my smallest exponent this time? X squared, because 2 is smaller than 4 is. So it's kind of weird. It's like biggest number for my coefficient, smallest exponent for my variable term. And again, all I'm doing here, and we'll do this one more time, is saying whatever I pulled out for my greatest common factor, that times something will get me my first term. And that greatest common factor times something will get me my second term. And if I'm not sure, I can always use the calculator even. If I didn't know 10 times what gets me to 20, I could always do 20 divided by 10 and I'd get the same answer, which in this case is 2. if I have 2 x's, that's what x squared just means, x times x. If I have 2 and I need 4, how many more do I need? 2. So 10 times 2 is 20. 2 plus 2 is 4. Okay, so 2x squared. Now this one's a little more interesting. 10 times what gets me to 10? 1. I already have 2 x's. I don't need any more. So sometimes it's just the number. And I'm done. So is there a little bit of work to this at times? Yeah. Yeah, there's a lot of thought process work in here with these. But it's just one of those things that we just sort of get ourselves used to a little bit. Absolutely. Okay. Now let's bounce around a little bit here, because I know there's some that look a little more odd. So like, let's say number 4. Let's go down there. So if I go down to number 4, now I got 3 terms. Yep, I got 9, and I got 81. So if I move this up a bit, let's see, am I going to cover my, yeah, I'm going to cover it up a little. But I notice, I'm like, okay, there's a 9. Okay, there's an 81, and they're in the same row. So 9. Okay, that makes sense. 9 goes into 9, 9 goes into 81. Okay, so 9. Do all of my terms have an m? No. So I can't take an m out. For me to be able to do that, they all have to have it. So all I get to pull out this time is the 9. And right, 9 times what gets me to 81, okay, would be negative 9. And if I wasn't sure, again, I can use the calculator and divide, or I know I keep coming back to the chart over and over, but again, it works because if you find 81 divided by 9, and if you go up the other way, equals 9, because it's 9 times 9. Huh? And since I don't have any m's out here, I have to include them inside the parentheses, because when I multiply these together, I should get that back. So then I go, okay, so we got a plus. 9 times what gets me to 9? Well, that's 1. But it's got an m, and there wasn't one out here, so I got to count that. And then I just got done saying, oh yeah, 9 times 1 gets me to 9. Okay. So again, just because they're big doesn't mean they're necessarily hard. It's just there's one more step I've got to take. So they can get really interesting here. Let's get a couple more of these here. Let's see. I'm thinking 5 and 6 are prime candidates. Yeah, number 5 is a little tricky because remember, what number's in front of a variable if I don't see one? Okay, it's a 1. So I'd be looking for a number that divides into 1, 2, 6, and 8. Well, it can't be any bigger than the smallest number is. So in this case, all right, I can pull out a 1. It really doesn't do me a lot of good, but we'll try. Do all of my terms have a's? Yep, they all have a's. I take the one that has the smallest exponent. So 1a to the first. Get my parentheses set up. Yep, and I go 1 times what gets me to 1? Oh, that's 1. If I have 1a, and I need to be up to 4, I need 3 more. Because 1 times 1 is 1, 1 plus 3 is 4. 1 times negative 2 is negative 2. Like, aren't the numbers just going to be the same? Yep, with 1 they will be. I have 1a, I need 3, so I need 2 more. I'll plus the 8, I got 1. I need to get to 2. I need 1 more. And 1 times negative 6 is negative 6, and I already have 1a. I don't need any more. But that's the thought process we're trying to go through. Holy cow. Oh, I'm trying to find a doozy. Ooh, I found me one. Number 7. All right, so number 7. I need a number. Yep. I need a number that multiplies. we can squeeze it in maybe here at the bottom. If I move the sheet up, I definitely can.
6.
Yeah. Because again, this is another one of those, if I'm not careful, I can get caught. Because I notice 12 and 18 are at 2, but then I start to move down a little further. Ooh, 12 and 18 are at 3. Let's go a little further just to make sure. Ooh, 12 and 18 are down at 6. That looks like it's the biggest one. So I'm going to pull out a 6. Do all of my terms have x's? Oh. All of my terms do have x's. But again, it's the smallest exponent that I use. Do all of my terms have y's? No, the third one doesn't, so I cannot take any y's out. They will get included later. So now, I just start the process. 6 times what gets me to negative 18? Now let's say I'm not sure. I'm like, I don't know, shoot. So, okay, here's my plan. I'm going to take the number I'm trying to get to and divide it by the number that's on the outside. Okay. Okay, let the technology help you if you need it. And then again, I have 2 x's, I need 3. I need 1 more. I don't have any y's, so I need all of those. It's just like putting together a puzzle. Now I just got done with 18, so I don't have to do that again. 6 times 3, I know that now, is 18. Got 2 x's, I need 3. Get that taken care of. I don't have any y's, but I need 1, so I put that in here. And then if I'm not sure on the negative 12, again, take that, divide it by the number that's on the outside. So that would be negative 2. I already have 2 x's. I need 2 x's. I don't need any more. I've got that ready to go. And again, sometimes the number in common will be 1. Sometimes it'll be a big number. It just depends. Let the chart help you if you're not sure. Now, though, okay, let's do number 10, and then we'll head to the back for a bit. So number 10, all right, let's look at the numbers first. We got 10 and 9 and 5. 10, 9, and 5. All right, I see 10, 9, and 5 at 1. There's 5 and 10, but no 9. Yeah, looks like it's just going to be 1. Okay, so we get a 1. Do all my terms have a b? Yes. I'm going looking for the smallest number. I see a 3. Do all my terms have a's? No, the first two do, but this one doesn't. So I can't take out any a's. So let's see here. 1 times 10 is 10. I know that. I already have 3 b's, so b to the third I'm good. But I didn't have any a's I pulled out, so I got to include that. Because again, my goal is, if I were to distribute or multiply this back out at the end, I'd get my original problem back. So 1 times 9 is 9. I've already got all 3 of my b's, but I need those a's. So a to the 5th. And then finally, 1 times 5 is 5. I got 3 b's, I need 4. What do I still need? 1. And this side, in a nutshell, is what we were doing the first day, the second day, and the third day that we were working on this. This is just sort of our way of building up, okay? So if you're just asked to find the greatest common factor and factor it completely, you'd put the parentheses at the end and you'd be done on one like this. However, when we flip over to the back, ooh, there's a couple of dandies here. Let's do one of the dandies up at the top here. And then we will get back into diamond mode here a bit. So I look at these and I go, ooh, that's kind of ugly. So let's take a look at number 11. Okay, 27, 63, 9, and 18. where do I see all 4 of those? There is a place somewhere on my chart that you can see on the screen where all 4 of those numbers up top show up. 27, 63, 9, and 18. And if you don't have one of the green sheets that I've got up, they're still over there in the bin. They kind of stick out like a sore thumb with that nice green color. So I start to look, and I'm like, there's 9, there's 18, there's 27, there's 63. They're all in my 9 row. So 9, and some of you may say, could I pull out -9 since I see a lot of negatives? You could. Doesn't matter. Either way, we'll get there. I notice all of my terms have a's. I just want the smallest exponent I see, which is a to the 2nd. What's my smallest exponent on my b's? 5. Okay. So that's my greatest common factor. Now I just start working in here again. And again, if multiplication is not your strength, let the chart help you, let the calculator help you. You're like, I don't know, -27, and then 9's out here, so I divide by that. Okay, -3. So -3. Now it's just an adding game. I already got 2 A's, I already got 5 B's. First term's done. So then I move here, and I'm like, okay, that's a negative. 63 and 9, I'm not sure. Oops, and I just did that the wrong way. So, no, Hardy. -63 divided by 9 is -7. I have 2 A's, I need 3. I need 1 more. How many more B's do I need to get from 5 to 11? 6. Because we're just adding on the exponents. So then I'm like here, I'm like, okay, to get from 9 to 9, that's just 1. I've already got my 2 A's. I have 5 B's, I need 6. I need 1 more. And then finally, I'm multiplying 9. I want to get to 18. I think that's 2, but we'll double check. Yes. I have 2 A's. I need to get to 4, so I need 2 more. And I have 5 B's, and I need 5 B's. Okay, that's cool. It is. It's a definitive process. And for some of you, the idea of getting used to a process is a good one, because a lot of jobs, you get to doing the same thing and you do it over and over and over. So it just kind of gives us some good practice. And then I don't know what happened to my directions here on the last part. What multiplies to get the number on the end and adds to get the number in the middle. I don't know what that 8's there for. So again, these are just my diamonds. These are just the ones where I go, okay. So I'm multiplying to -14. I'm adding to -5. And again, if I'm not sure, I could look it up on the chart, just find where the 14's are at. I always know that 14 and 1 would be an option with that number times 1. And I also find out that 7 and 2 could get there. But before I figure out which pair, there's always clues available to me in these. Yeah, if I'm going to get a negative number when I multiply, what do I know about the signs up here? I know one's going to be negative and one's going to be positive. It's the only way I can get a negative number when I multiply. And then I also know if I want them to add to a negative, the negative number's got to be bigger. So I'm looking, I'm like, well, 14 and 1, I can't add or subtract and get that to 5. That's no sense. 7 and 2, ooh, I can subtract. Yeah, that might work. If the bigger number would be 7, let's see if this works. I have $2. I borrow 7 from my friend. I owe him 5. That works. Positive times negative is negative. Okay, but I'm not quite done. Almost. Parentheses. Whatever variable you see goes first. And then the numbers that I have on the sides of my diamond are the values that go afterward. And again, that never changes on these. And again, for some of you, the diamond will help you. For others of you, the diamond, you're like, do I really have to draw that diamond out every time? You don't have to. But for me, I think a lot of you, it would help just because it's more visual for some of you. But I'm always multiplying to get the number on the end. And what number is there in the middle if I don't see one? 1. Positive 1. So again, let's do a little detective work. Okay, 6, I don't have a lot of options. It's 1 or 6 or 2 and 3. It's one of those two. So I look and I go, okay, it multiplies to a negative. So I know I'm going to have one of each sign. And since it's a positive, I know the bigger number has to be positive. Because otherwise, when I add them up, it won't work that way. Well, 1 and 6 ain't getting me to 1, but 2 and 3, they're 1 apart. If I do the bigger number, I have $3, I spend 2, I got $1 left. 3 times negative 2 is negative 6, awesome. So I've got, oops, K, that's my variable, and just copy the numbers. All right, I'm going to try to find a doozy here. I think 17 is going to be the closest thing to a doozy we get on this one. So let me scooch this down a little bit. All right, last one, then I'm going to have you try out on the rest here. Multiply to get the number on the end. Add to get the number in the middle. All right, detective work first. Multiply to get a positive. It's either going to be positive, positive, or it's going to be negative times negative. How do I know which one? What sign's on the adding part? Negative. Okay. Tells me they're both going to be negative. You're like, okay. So then, now 64 has a ton of options. 1 and 64 would work. 2 and 32 would work. 4 and 16 would work. 8 and 8 would work. But remember, the key is those two numbers I have to be able to add or subtract to get to 16. 1 and 64, they're too far apart. That doesn't work. 2 and 32, well, if I subtract them, I get down to 30, but I need to get to 16. 8 and 8 works. Okay, 16 and 4 doesn't work, but 8 and 8 works. And I know they're both negative. So I don't even have to worry about that part. X minus 8. X minus 8. Okay. So that's the practice we're doing today. Tomorrow it's going to be a blend of all of this stuff. The only other thing I didn't put on here was some stuff with the perfect squares. We're going to pound away at those tomorrow again. But otherwise, you're basically seeing everything that's going to be on the unit test. Okay? But again, if you're having issues, kind of use this to help out. If you've got some of the older sheets that you're still working with, make sure those get in. Because again, anything from this unit's due by Friday. Anything you see listed up on the back board is going to be stuff that needs to be into me by then. And some of that stuff's kind of old anyway. So that's about it for now. So the other sheet you saw, Mind Bender, extra credit, we're just doing diamonds. So this one I'm going to help out and make this go a little quick. Let's see here. Multiply to negative 24, so I know I'm going to have a positive and a negative. And I need to add to 10. Okay, well, let's see. Now normally, and this is where this one could be tricky, I look at my 24, 12 and 2, 8 and 3, 4 and 6. Now I look and I'm like, ooh, 4 and 6, that adds up to 10. But the signs are an issue. And I know it's going to be positive, so I know the bigger one's going to be positive. So I'm actually going to go with 12 and negative 2. But this time, I'm not quite done when I put it in the parentheses. Because there's this little thing called equals 0 there, which gives us some more practice. Because now whatever's in the parentheses when I get done, I'm going to set that equal to 0. And I'm going to solve each of those to get my two solutions. The nice thing is the answers for these are down at the bottom of the sheet. So once I find an answer, I'm going to know right away if it works or not, because if it does, I'm going to find that at the bottom and I'm going to be able to plug that in. But again, this is extra credit, but it's an assignment worth. So if you've slacked in some areas or looking for some extra points to boost your grade a little bit, this isn't a bad idea, and this would be due the same time. If you just do the mind bender side, it's +5. The other side's getting into more complex stuff. So if you want to tackle that, you'll need to see me and we can work on that too. So now we're set and ready to go.